Okay, this video I'm going to explain how the radar chamber operates. So the first thing you want to do, you want to power up the rotation stage, and you want to turn in the locking with the power switch on the back. And let those power up for a second. So on the lock-in now, after it's on, you want to go to the menu button, and then you want to go to signal channel, and you want to change that from AC to DC, and then back to the menu channel. So the lock-in amplifier is done being set up. Now on the rotation stage, you just have to turn the motor on. It's on the off, you just click that on. So from here now we're going to turn on the power source for the transmitter. And that would be this one right here, labeled 5.5 volts. It's already preset. All you have to do is turn that on. So now you can check that everything is working by looking at the indicator on the lock-in, and you can slow jog the rotation stage. There's a flat plate in the chamber, and you can see the measurements will change. And you can see how it's jumping up. Peak is probably somewhere right around here, so you know that the radar chamber is working. The next step is we want to pull up the proper software. And for that, we're going to go to LabVIEW. So just type in LabVIEW in the search. Click on NI LabVIEW. And you're going to click on 35 gigahertz measurement VI. And that opens up everything we need. You're going to scroll down here so that you see both the graphs. One's a log plot, one's a standard plot, and now you have icons you can change: start position, step size, end position, number of averages, acceleration, and max velocity. What you should do is once you load in your sample, you want to find where the peak is roughly for your return signal. So now what you'll do on the rotation stage is you want to set that peak to be your new 0 position. So you would go menu, and you're going to click down, reset positions, click over one, hit clear, OK, and now the rotation stage is set. So from here, you can change your start position and your step size and your end position. So I'm going to change my start position to -10 for this example. I'll do a step size of 0.5. End position, I'll do 10 degrees. And I'll leave it at 10 averages, and I'm going to leave the acceleration and the velocity. So then you click the checkbox and then the run arrow, and now the program will run. There is a flat plate in the radar chamber. So it'll begin running the program. You can see the graph begins to populate. When the program's done, it automatically asks you to save it as a file name. You save it, click OK. And now we can open MATLAB. You want to open up the plot measure program. This is set automatically to run. All you have to do is literally up arrow so you get your plot measure. On the bottom, hit enter. And then what you're going to do is pick your file that you just ran your test with. Click open. And normally you would do a background, but for this example I did not do a background. If you do not do a background, we have a blank 400. You can use that file. It's literally just a blank file. Click open, and then it'll present the graphs in MATLAB.